Looks like you've all decided to come back and join me again. So glad you did. Last week, we spent some time talking about outsourcing all or part of a project. We talked about the advantages, the disadvantages, and the best practices. This week, we'll spend this time talking about measuring and evaluating performance and progress. We're now on Chapter 13, Progress and Performance Measurement and Evaluation. We've made quite a bit of progress and getting closer to the end. In order to measure or evaluate performance or progress, you need to have a monitoring system in place. You may have heard this referred to as PMIS, or Project Monitoring Information System, or PMSS, Project Monitoring Surveillance System, depending on the industry or sector you're in. PMSS is the most commonly used in the federal sector. To create a monitoring system, you need to determine the following: what data to collect, how, when, and who will collect the data. For the how, this would include determining what mechanism the company will use. Will it be Microsoft Project, Excel, an enterprise-wide accounting system? When? How frequently? Will it be collected daily? It's doubtful, but weekly or monthly are common timeframes. It will depend on your needs. As for who will collect the data, it's usually the project manager or an analytics department. How to analyze the data. What is the data telling you? Finally, how to report the current progress of the project to management. This may include who will receive the data. Project team members may receive all the data, while stakeholders would receive a higher level of detail from the data. Once you determine your needs in creating an information system, you need to determine its structure. First, you will need to determine what data are collected. You'll need to consider the following: current status of the project, where are we with schedule and cost? Remaining cost to complete the project. This may also be referred to as the estimate to complete the project. Date that the project will be complete. Potential problems to be addressed now. This may include data such as variance of cost and schedule or deviations from the plan. To determine this, you'd look at your plan versus actual performance to see where potential problems might be. Out of control activities requiring intervention. The information for this comes from the analytics. It paints a picture of how severe the deviation is from the plan. Cost and/or schedule overruns and the reason for them. This is one of the main reasons we monitor, to see overruns and determine the reasons behind them. This final one is never stressed enough. It's forecast of overruns at time of project completion. This paints a picture of the budget and schedule at completion. It's what the endpoint looks like. In addition to deciding what data are collected, you'll need to consider the collecting and analysis of the data. For instance, who will collect the project data? How will data be collected? Will it be through a back-end accounting system, desktop software, or individual project team members' input? When will the data be collected? This could be weekly, monthly, after certain milestones are reached. This will vary greatly from one company to another. Who will compile and analyze the data? The compiling may occur automatically using software or by the project manager. Next, you need to consider the reports and reporting. Consider the following: who will receive the reports? The answer will come from your communication plan, which we discussed in Chapter 4. How will the reports be transmitted? And when will the reports be distributed? You've considered the necessary information for collecting the data, and you know the data needs to be formatted in a way that is useful to others. Here's a very traditional look at how progress reports are formatted. First, list any progress that has been made on the report since the last report. Next, provide the current status of the report. Be sure this addresses the schedule, cost, and scope. Following this, you'll want to list any cumulative trends you see happening within the project. You'll want to include problems and issues since the last report. Be sure to indicate the actions and resolutions of earlier problems and new variances or problems which have been identified. Finally, you'll want to create and share an action plan. This is really a broad look at how you might format your reports. Again, this is a very traditional way, and you and your client may find a format that works better. So now we move to the controlling process. What is the controlling process? It's the method behind comparing the actual performance of a project against the project's baseline plan. The control process identifies variances between the two. It assesses or identifies the problems and implements a course of action to correct things. Here are the basic project control steps. 1. Set a baseline plan. We've talked about the baseline in earlier lectures. 2. Measure the progress and performance. 3. Compare plan against the actual. 4. Create an action plan, or take action. A couple common but fundamental tools used to do this include tracking and baseline Gantt charts, we'll cover this in a bit, and control charts. These provide us with an illustration of the cost and schedule regarding how far we've deviated over each period of time. Here are examples of the baseline and tracking Gantt charts. They should at least look familiar, as you were required to create a Gantt chart for the Greendale Stadium case study earlier in the semester. These are developed using activity and node networks. The top is the baseline Gantt chart. It's a frozen point in time representing the best expectation or plan to get to the end of the project. The bottom is the tracking Gantt chart. It shows the status through, at this point, period 6. You can see that the time now line, which is the vertical dashed line, is at period 6 for time. On the left-hand side of the time now line, you can see the blue shaded cells below the baseline cells. These indicate tasks which have actually been completed. In this example, tasks A and B have been completed, and we're only a bit behind on task C. When you don't complete the tasks on time, each task is pushed further into the future, and that's what you see here, the remaining duration. Since there are dependencies from finish to start on future tasks, if you're late on one task, the other tasks are pushed out. This isn't something that should alarm you. It just shows that your best expectation or best plan isn't coming to fruition. Because you know this, there won't be any surprises later in the project that you won't make your original completion date, because you knew about it early on. Here's an example of the control chart. It has the same reporting periods we saw on the previous slide with the Gantt charts. We can see the time now is still at period 6. According to this, the project is 3 to 4 days ahead of schedule for right now. If we look back, we can see that during time period 3, the project was about 3 days behind schedule. This could have been due to staffing issues. The project was just starting and the company was waiting for resources to finish up on other projects. Once they did, staffing was at normal and they were able to make up some of the lost time, and then some. So the difference between monitoring systems, I have to tell you, there are as many monitoring systems as there are projects, really. And it depends on the experience of the project management team, which monitoring system and status reporting systems are put in place. The time phase baseline plan. You basically have different reporting periods set up in the baseline plan. This is meant to correct the failures of most monitoring systems to collect a project's actual performance to its schedule and forecast budget. So it's comparing actual performance against a baseline plan. The Earned Value Cost Schedule System is an old system developed in the 1950s for defense and space projects. It's also known as the EVMS, or Earned Value Management System. It's an integrated project management system based on the earned value concept that uses a time-phased budget baseline to compare actual and planned schedule and costs. Here's a list of terms which you can find in your textbook. Everything in this glossary really revolves around the top 3 terms: earned value, planned value, and actual cost. Most of these terms will be new to you, so please spend some time reviewing the terms. Here we are, back to the WBS, a term from the early stages of the text. First, using the WBS, we can define the work: scope, work packages, deliverables, organization units, resources, and budgets. If you think of this like an org chart, scope, work packages, and deliverables would be the vertical segments, with organization units, resources, and budgets being the horizontal segments. You apply resources to the work packages, certain tasks make up the deliverables, and you assign budget to those resources. Building your WBS leads you to developing your plan. Next, we need to develop work and resource schedules. We schedule resources to activities and time-phase packages into a network. We develop a time-phased budget using work packages included in an activity. This provides you with your accumulated budget or planned value. At the work package level, you collect the actual cost for the work performed, AC. Multiply % complete times the original budget, and you have earned value. Then, you do your computations and create your schedule variance and your cost variance. Schedule variance is determined by subtracting the planned value from the earned value. The cost variance is determined by subtracting the actual cost from the earned value. Here's a great visual of what we just talked about. You have your traditional WBS up on top, and it contains all the scope and deliverables. Then, the horizontal side of this is the Organization Breakdown Structure, or OBS. You'd have the design organization and the test organization, and you break those down into work packages until you hit the deliverable. Then you allocate time, or cost, they can be used interchangeably, to the deliverables. So you attribute the progress of deliverables to actual resources applied through the OBS, so that you can get costs allocated to organizations tied back to project costs. Then we use plans and schedules to create baselines to depict all of that. You freeze the schedule and plan into the baseline before you start actually posting time and costs against the plan. Next, you move to control. And this is the project management system overview. This actually has a lot of information in it, so be sure you take your time when reviewing it. Now we get into the development of the project baseline. The purpose of the baseline, or the planned value, is to create an anchor point, the point where you freeze the plan so you have a point of reference. This point becomes the point from which you will measure cost and schedule performance for each period of status reporting. Having a planned cost and expected schedule allows you to measure your actuals against your plan and compare the two. It's plan versus actual from a cost and schedule perspective. This provides a basis for cash flow, or the demand of cash for the organization. Next, you have a summation of time-phased budgets along the project timeline. To do this, you allocate costs by work package to create your budget along the timeline. You now have your baseline, and you will use it to measure performance and progress against until the completion of the project. So, what costs are included in the baseline? As a project manager, my response would be, every single cost you can think of would be included in the baseline, because you're going to be measured against that going forward every period. The book will tell you it includes labor, equipment, and materials. These make up DOC, or direct overhead costs. We also need to understand the rules for placing costs in a baseline. You will allocate costs to the period you expect to use them. This happens at the beginning of the project using your best guess or best estimation. There's also the percent complete rule. Let's say you're in week 5 of a 10-week project. You might think the project is 50% complete. However, that may not be accurate. Percent complete is the work that has already been completed, the work that is behind you, compared to your estimate. Now let's take a look at some methods of variance. Remember, planned value is the baseline, so everything is measured against the baseline. You also have earned value, which is determined by the expected schedule value and the actual costs that you incur. Earned value is really the costs and schedule components compared to the planned value or the baseline. Again, PV, or planned value, is the budgeted cost of the work scheduled. It's the cost of the work as seen on the baseline. Then there's EV, or earned value, which is the budgeted cost of the work you have completed. And finally, there's AC, or actual cost, which is the actual cost of the work completed. Now that we've covered the basic terms, we'll use them to analyze other variances such as cost and schedule. You can probably imagine what cost variance is. It's the difference of your actual costs against your planned costs in the schedule. It's measured periodically, period by period, and then cumulatively to date from the project start. Schedule variance is similar, only instead of using cost, you use schedule. It shows, in dollars, the progress of your work completed to date compared to your baseline or planned value. The graph here shows you each of the variances. You have your baseline plan, the PV line, it's the one in the middle. You can see it looks a bit like an S, and it is sometimes referred to as the S-curve. This type of curve is very common in the baseline. The today line is shown by the line down the middle. Your actual performance is measured against the baseline using earned value, the bottom curve, versus the planned value, the middle curve. If you take the EV, or earned value, minus the PV, or planned value, you get the schedule variance. To determine the CV, or cost variance, you look at the difference between earned value versus the actual cost. So cost variance is EV minus AC. On the right-hand side of the graph, there are two acronyms, EAC and BAC. EAC is Estimate at Completion, and BAC is the Baseline at Completion. The EAC is an updated estimate of the cost you will incur as a result of what you know has happened in the past. This will take some time to sink in and fully grasp. Therefore, I recommend walking yourself through this using your textbook as well. Here are some examples of what the curves might look like with a combination of negative and positive schedule and cost variances. The planned value continues to the end of your period. Remember, it's your baseline which you laid out at the beginning of the project. The actual costs and earned value are periodic. Value is earned as you move through the project and costs are incurred. None of these show if the project is on target for cost and schedule. If it is on target for cost and schedule, your variances would appear on the baseline or S-curve. Now that we've looked at some measures, let's talk about how and where these might appear in the development of a status report. The example provided here is not only hypothetical, but also oversimplified. And perhaps that's a good thing as we walk through this and learn. The assumptions are, each cost account, which ties back to the work breakdown structure, has only one work package, and each cost account will be represented as an activity on the network. The project network early start times will serve as the basis for assigning the baseline values. From the moment work on an activity begins, some actual costs will be incurred each period until the activity is completed. Here's an illustration of the OBS or Organization Breakdown Structure on the horizontal versus the WBS or the deliverables on the vertical. The illustration is pretty accurate to what you would see in the workplace, with the exception of having one deliverable assigned to an organizational function. For instance, a design specification will often have several tasks associated with it. Thus, more than one deliverable is likely to appear in the design/design specification box. Again, this is a very simplified example. These actually get very complicated. But this is a useful method for learning how they are created. Once you understand the simplified version, moving to the more complex is much easier. Here's an example of the baseline Gantt chart. You can see there aren't any actuals posted against it. It does show that the design spec is 2 periods, and there's a finish to start dependency on the shell and power activity. Activity B, the shell and power, also has a duration of 2. This Gantt chart shows the baseline duration along with slack, depicted by the blank portion of the activity rectangle. Activity B has 2 periods of slack. That means it can be 2 periods late without impacting the next activity. If it's over 2 periods late, it will impact the start of activity E, assemble. And here's an example of the project baseline budget, a very standard format. You've seen a lot of this information already. Remember early start, late finish, slack, etc. We're just using the information and elaborating on it. For instance, you now see that baseline budget needs is above time period. This is just one step further from what we covered earlier in the course. This chart shows us the early start, late finish, and associated slack, which we saw on the previous slide. Now we have the total planned value, which is given to you here. This would be your baseline plan for each activity. On the right-hand side, under time period, it shows the distribution of the budget, or the planned value, over the periods. Again, this is a very standard format. After going through all of those steps, we can now develop the status report. This example of a status report will lead you through 7 periods of the project. This slide shows us periods 1 through 3. The next 2 slides will take us through to period 7. If a task is live or has activity associated with it according to the baseline, it will appear in that period. For example, activity A had a duration of 2, if you'll remember. Therefore, activity A is listed under periods 1 and 2. Across the top, we have the 3 critical metrics: earned value, actual cost, and planned value. Under PV, we have what was planned during period 1. Under AC is what was incurred from a cost perspective, and under EV is what was earned from a dollars perspective. From this, you can create your variances based on the equations at the top of the slide. The cost variance deals with the actual cost that has been incurred. The schedule variance comes from your baseline planned value. Typically, For summary status reports, you report cumulative totals by period as well. This is the same example from the first slide. The only difference is that this one provides information for periods 4 and 5. And this slide finishes up the status report by covering periods 6 and 7. The information you see here is formatted the same way we discussed for periods 1 through 5. The graph you see here displays the information we just covered for periods 1 through 7. You can see the S-curve here, or the baseline. It's the planned value curve. You can also see the performance, or earned value, what you've earned. So earned value, or EV, and planned value, or PV, create schedule variance. The difference between the two gives you your schedule variance. In this example, schedule variance is negative 40. To look at the cost side of things, in order to identify the cost variance, you use earned value and actual cost. The difference between those provides you with the cost variance. In this example, the cost variance is negative 70. Another thing to keep in mind is that these terms are all expressed in terms of dollars. We'll now take a look at the tracking Gantt chart using the data from our example. This provides your actual performance through today. Using the legend at the bottom, you can see that Activity A started and finished on time, while Activity B took 1 period longer. That creates a variance in period 4 because your activity is not complete. The earned value will be under the planned value curve. This example provides a good illustration of what happens when activities are not completed within the original time frame. As an activity's duration is pushed out and the activity isn't completed by the original estimate, it creates variances and you start pushing work out. This happens due to the start-finish dependencies. Looking back at this example, you can see that Activity C was supposed to be finished at period 6 so that Activity E could begin. Unfortunately, that didn't happen. Activity C is still being worked on, and Activity E can't start until Activity C is finished. Here's a look back at the WBS and the OBS depiction of all the work packages. The scope and deliverables by organizational unit. This updated illustration shows the costs associated to the organizations that contribute to the completion of the project. You can see that schedule and cost variances have been added here as well. There are a few performance indices in addition to the previous metrics we just covered. Let's look at the first two, cost and schedule performance indexes. These provide you with your efficiency project to date. It gives you a prediction, both on the cost side and the schedule side, of what cost and schedule will look like at project completion. You can use these performance indexes to show what your current expectation is of coming in around the planned completion for cost and schedule. The equation for cost performance index is earned value divided by actual cost. The equation for scheduling performance index is earned value divided by planned value. These two indexes are used quite a bit, actually. A spin on these is the percent complete indexes. There is some debate going on as to which to use. You can use either the percent complete index budget, B, or cost, C. The rule of thumb is to use the one which, at the current time, you have the greatest faith in. Do you have more faith in your budget at completion, which is included in your baseline plan, or do you have more faith in your current estimate at completion? The PCIC is more current, meaning it has more information in it. It has actual performance in it and gives you an opportunity to compare the two. Now that we've covered the indexes, let's look at what the results mean. If either index is greater than 1, the interpretation of this is, from a schedule perspective, you're getting more out of every dollar spent than you originally planned. I think of it as the project has been more efficient than planned. So a CPI or SPI greater than 1 is that you are not using as much schedule as you planned, so you're ahead of schedule, and or you're under cost. When the CPI or SPI is equal to 1, which is very rare, it means you are on the baseline plan. From a cost perspective, less than 1 means you're not getting the dollar's worth of work out of each dollar expended. And from a schedule perspective, it's taking you longer than you originally planned in your baseline. Here's a graph representing the performance indexes SPI, CPI, and PCIB. If you were on schedule at your planned budgeted costs, the performance indicator would be at 1. This graph here indicates that the project is not going as well as planned from either a cost or schedule perspective. There are some additional rules for earned value. Let's talk about these real quickly. First, it's important to stress the short duration part of the rule. These are best used for up to a week at a time. Anything more than that decreases the accuracy. The 0 to 100% rule means that you either earned 0 credit or 100% credit. If you haven't delivered the product to the plant, you've earned 0%. If you have delivered the product to the plant, you've earned 100% credit. The 50-50 rule means that when you are halfway done with an activity or deliverable, you take 50% credit from an earned value perspective. This is all from an earned value perspective. You don't earn anything until you actually complete it. That's why the rule is for short duration. If you have a 6-month project and you don't get any credit until you're complete, that's not a real accurate portrayal of where you are. Here's another concept you'll come across in your project management career. Let's say you had a certain amount of work that was planned versus what was completed, and subsequently, you knew that your estimate for your baseline was off track. If your SPI or CPI is less than 1, indicating you weren't as efficient as you originally planned, you may come up with a new estimate at completion. The top function, EACRE, is the estimate at completion revised. This allows for a change to the original baseline durations and costs due to the new information indicating the original estimates were not accurate. The bottom function, EACF, is the estimate at completion forecasted. This uses actual costs to date plus an efficiency index to project final costs in large projects where the original budget is unreliable. Here are the equations for determining the EAC revised and the EAC forecasted. AAC is the actual performance from a cost perspective. That's what's behind you. ETC, the estimate to complete, is what's in front of you. Using the two of these numbers together provides you with a new estimate at completion from a cost perspective. There are many different equations you'll find for project management metrics, but here we're focusing on the basics. Those include the previous metrics, EV, BAC, AAC, CPI, etc., along with the newer ones listed here. Finally, we now have a completed status report. The status report is what we use to monitor and measure how the project is proceeding through certain time periods. This example shows a monthly status report. However, you'll see some organizations do them weekly or bi-weekly. A lot of it will depend on the risk of the project, the type of industry, or the costs associated with the project. You'll see at the top it provides the project manager, holding them accountable for the project and data found within the report. It also provides the full set of metrics that we've learned about today. Notice here that PCIB and PCIC are really rather close. This indicates that variance is rather low on the cost and schedule side of things. Then you have the project description and the summary. In the summary, you identify the variances which you have also listed above. In the explanation portion, you provide the reasons or thoughts behind the variances. Next, you'll list any major changes in the project since the last report. This is also where you would provide any corrective action taken since the last report. The information you see here is pretty standard, with a very brief summary of the status. In maintaining the control of projects, the project manager deals with the issues of scope creep, baseline changes, and the acquisition of costs and problems. To maintain control, the project manager needs to ensure that a change to the scope or baseline does not occur without going through a constructive change management system. Doing this ensures you have obtained the appropriate approval, ensured that people understand the changes, and that they will be well communicated. The following information should be provided in the communication: what the change is for, why the change is happening, and what the ramifications of the changes will be. There are several reasons why you might need to change the baseline. It could be due to a poor CPI or SPI, the use of virtual teams, sickness, or unplanned events. When scope changes occur, it will impact the baseline. Here you see that an increase in cost creates a new baseline. In this example, the new baseline curve is labeled as New Baseline A Cost Increase. Or you might somehow realize greater efficiency than you originally planned, and it isn't going to cost you as much as you originally planned to complete the project. That would be represented by the curve New Baseline B Cost Decrease. Try to think way back to week 3 when we covered Chapter 4. That's when we talked about communication plans. Here's a list of the different types of reports containing different sets of information which will need to be distributed throughout the project. Under when, you have the frequency, how often the particular report will need to be distributed. Under responsible, it lists the person who will be compiling and sending the reports, and the recipient column tells us who will be receiving the reports. And with that, we sum up Chapter 13. We've spent this time discussing metrics which help the project manager measure and evaluate a project's progress and performance. We elaborated on what a baseline is, discussed planned value, earned value, and several other variance metrics. We've looked at several examples of how these metrics can be applied and interpreted. It's not all straightforward, so I would highly encourage you to go back through these examples and the metrics using the textbook for reference. So next week we'll be taking a little break for the Thanksgiving holiday. When we return, we'll be covering Chapter 14, Project Closure, and Chapter 15, International Projects. We will only cover 14 in the lecture, but there will be a Chapter 15 option in the weekly discussion topics. Speaking of weekly discussion topics, let me stress again that these are not optional. They are graded. Apparently, some people are still under the assumption that they are optional. Please note, they are required. Okay, hopefully this is the last time I need to say that. Have fun this week getting acquainted with EV. It's not that difficult, it's just different. I hope you all have a fun and safe holiday. See you next time.